All right, so here we go with 7.2. So let's jump into this here. It says identify the pairs of congruent angles and corresponding sides. Okay, so we can do that. Let me get a pen first. That would be step 1. So pause the video if you don't have a pen yet. Go get one, make sure it works. Bam, we're good. All right, what I'd probably do is just mark this third angle with 3, just so it's pretty easy to identify them. So we'll start with the 1. We'll say angle U has to be congruent to angle M, and of course vice versa is fine. And then we'll go 2. Angle V is going to be congruent to angle N. And then finally we have angle W has to be congruent to angle, congruent to angle P. All right, and then it says corresponding sides as well. All right, so as far as the sides, again, they're corresponding, but they're not, we know that they're proportional, not congruent, so I'll write them in a proportion. So let's just say, okay, we'll just start with the one between 1 and 2. So that's going to be 4. We'll start with this one because we did that already. So 1 and 2 is 8. So we'll say 8 over 4, right? Because the one between the 1 and 2 is, VU and MN. Okay. And then we go down to the one between 1 and 3 is going to be 6 on the big triangle. And the one between 1 and 3 is going to be 3. And the one between 2 and 3 is going to be 4. And the one between 2 and 3 is going to be 2. And if you notice, they all have a scale factor of 2 over 1 or 1 over 2, depending on which way you did it. All right, so let's look at the angles in this case. We got 4 angles going on here. Okay, so we could do angle A is going to be congruent to angle H. They're marked already. We have angles, work our way around. Angle B is going to be congruent to, well, we went from H, we'll go to J, right? Oops, angle J. And then we have angle C is congruent to angle K. Angle D is going to be congruent to angle, where was I? D. No, where did D? DL over here. Bam. All right. And then we have the sides. All right, so we'll do, in this case, these are both kites, actually. You can tell by the congruent sides. So we could do like 8 over 12 equals 8 over 12. And then we could do, of course, 4 over 6. And then another 4 over 6. So all those would be reduced to 2/3, which would be good. They're all same scale factor. All right, determine whether the polygons are similar, and then if so, write the similarity ratio and similarity statement. Okay, so we should determine if they're similar. In this case, these are rectangles, so we know that like these sides are congruent. So all I really don't have to do is check 2 ratios instead of the 4 because we know they're going to be the same. So I'm going to say, well, is 45 right over? I'm not going to mark it as congruent. I'll mark it as sort of a squiggly. Over 30 equal to 135 over 90. And so we can check that, like I said before, we just cross multiply and we get 45 times 90 is 4050. And we're going to check to see that it equals 30 times 135. And it's 4050. So these are proportional. So because they're proportional, we could say that they are similar. And so we could figure out their ratio. If we reduce 45 over 30, we're going to get 3 over 2. So our similarity ratio is just take one of these. That's 2, sorry. Take one of those and reduce it. Either one is fine. And then we can write our similarity statement. So we're going to go, I'll just say sort of a rectangle A, B, C, D would be similar to, hang on one second. Well, we can do this. We could look at AB as this top sides, right? So we could do EF, GH. Actually, it's in order. EF, GH. Take a minute to look at that, I guess. Actually, not a minute. I'm just going to open the door for my dog. Hold on. All right, here we go. Okay, do the same thing for this one. In this case, we have to check if all of them are the same. So we'll go ahead and say, all right, well, 4 is the smallest, so we're going to put it over 6. I'm going to check these ratios, and then we go 8 is the next biggest, and then 10. And so we'll just go the same order, right? 4, 8, 10. So we're going to go 6, 12, 15. And again, we can just sort of cross multiply and double check. We've got to check them individually. So we'll check this one first. And we'll say 4 times 12 is 48. 6 times 8 is 48. So that looks good so far. And then we'll do this one over here. We'll say, well, 8 times 15 is 120, and so is 12 times 10. So these are proportional. So because they're proportional, we can reduce this again to 2/3 as our. I just would pick any of them and reduce them to 2/3. Right? They're all going to be reduced. That the similarity ratio is just the ratio that one of the sets of corresponding sides reduces to. Okay, and then finally we can write this out. We can say triangle. We'll just go. We'll start sort of with the small, medium, large side. So we'll just go PRM. PRM is going to be similar to triangle, and then we'll sort of start in between the largest and the smallest. So that's going to be largest here and smallest. So U, and that matches up with that angle anyway. So U, X, W. Yeah. And again, really, there's a lot of ways to match them up, but I'm thinking, okay, I went from the vertex with that were the congruent, right? U and P are congruent, to the one that wasn't marked, R and X, so we just match those up. Okay. Identify the pairs of congruent angles and corresponding sides. All right, we'll do this again. In this case, we have to sort of recognize that this is kind of flipped here, and so we want to make sure we're matching things up. Where we can go small, small, medium, medium, and so on. So we'll sort of say angle J is congruent. So we'll just do JKLM, JKLM. I'm just getting all my congruent symbols written at the same time here. So these angles are congruent. So J is going to be congruent to S in this case. And I'm basically thinking, oh, it's the one between the one and the other right angle. So the other right angle and the one is S. Okay, and then we go K, which would be T. Again, you can think of it as, well, that matches up. Those are pretty clear. And then U is going to be the next one. And then we only have one left, and that's V. So we're good there. All right, write a proportion now. So again, this is not so bad. I'll just stick with this one and do just the, I can just write them in order. So I'll go 10, and then the next biggest is 14, and then 20, and then 30. And that way we know we'll just do the same thing as far as the order goes. We'll start with the smallest, which is 12, the second biggest, which is 16.8, third is 24, the biggest is 36. And so there would be your sort of ratio there, corresponding sides matched up in the ratios there. We're kind of doing the same thing here. We have angle, I'll just do A, B, C. This big triangle here, that's a horrible symbol. It's harder than it looks to draw on this thing. Okay, so we have which angle? Well, angle A matches up with angle X. Angle B is going to be Y. Angle C is going to be Z. Yeah. Okay. And then we could just, again, go A to B, which would just be X to Y. We already sort of have them matched up. So A to B, it's going to be 8. Again, I'm just doing them different ways, just so you can see them different ways. Of course, you could do the same thing as I did last time and go small to large, whatever, but I'm just doing A to B. And then, so A to B would be the same thing as X over Y. So X over Y is 4. And then we do B to C, which is 6. And B to C would be Y to Z, which is going to be 3. And then we'd have 12 left and 6 left. And you can see those are all reduced to 2 over 1. So we're good there, but those are the proportions. Those are the corresponding sides. Again, you could have, in this case, if you wanted to write them out, and again, you could write them with their numbers because they do have numbers. But again, it probably would have been just as good to write them out, A, B, B, C. I think this is how I did it in class, so I think I'm backtracking a little bit. But you can definitely do it like this as well. Because they have numbers and they're unique numbers, you can check them out. I think I probably should have done them this way. I'm not going to go back now, but you can match up the numbers up there. But BC is XY. It actually is probably even easier this way because you already have the numbers here, or the sort of the symbols here. But either way, that's sort of what it would be here. And again, while I'm at it, I guess I could. No, I'll stick with it. We'll move along. Okay. If there's any more of those, I'll do them the same way. All right, determine whether the polygons are similar. If so, write the similarity ratio and similarity statement. Same things as we did before. All right, so are they similar? So we have to sort of match these up. Well, we have to check the angles if we can. Well, 53 and 37 is 90. So this one, again, has to be 53. So angles-wise, we're good. Now we just have to check the sides. So if we check the sides, we can, again, let's go in order. We'll go 21, 28, 35, and then this would be 24, 32, 40. And we're just checking that those are. And if you divide them out or reduce them, right, 21, again, a lot of people just divide them out and get 0.875, for instance, in this one. So the 28 divided by 32 is the same thing. 35 divided by 40 is the same thing. Or you can cross multiply, but either way, you're going to get the same sort of ratio there. So we're good. So they are good. Now we just have to write the ratio. And again, the ratio is just going to be a reduced version of one of these, which just ends up being 7/8 or 7/8. And then we can write it as, let's go with triangle, I don't know, RSQ is going to be similar to triangle. Well, R, again, we can say would be the 37-degree angle, so that would be U. S is the right angle, which would be Z, and 53 would be the last one, which is X. So those would match up there. These are rectangles, so again, we just have to sort of check one. We can just check to see if 18 over 24 is going to be equal to 36 over 54. Again, in this one, I will cross multiply, so 18 times 54 equals 972, and 24 times 36 is not the same. So 18 over 24, 36 over 54. Just double checking I did that right. 18 times 54, 972. 24 times 36 is 864. So these are not similar. So not similar because those aren't proportional. So I don't have to do the other parts. All right. Each statement is sometimes, always, or never true. Two right triangles are similar. That would be sometimes. They can be. They only have one angle exactly that are going to be congruent. So we don't know for certain. These I think will be a little bit easier to do once we do the later sections. Two squares are similar. That is always. They're always going to have the four right angles in there. And the sides are always going to be proportional because they're going to be the same size as all the other sides. So, all right, a parallelogram and a trapezoid are similar. That would be never. Again, a parallelogram has both pairs of opposite sides being parallel, and a trapezoid only has one pair of opposite sides being parallel. So there's no way that those angles could be congruent. So they can't ever be. So they won't ever be similar. If two polygons are congruent, they're also similar. That is always true. If they're congruent, it's sort of like they go beyond being similar. They have congruent angles and congruent sides and not just proportional sides. If two polygons are similar, then they're also congruent. That would be sometimes. So in other words, it's possible. It's kind of like the reverse of this one. It's possible that because things are similar, they could be congruent, but not necessarily all the time. All right, got a few more here. All right, find the value of x. In this case, we're just using the fact that these figures are similar to write a proportion. So I could say, all right, well, 4 over 3, right, the ratio of these two sides is going to match up with the ratio of these sides. Right, so when I cross multiply, again, I would say the main thing here is, I always make sure to write out this step because that way it'll hopefully remind you to distribute. So 3x plus 9 equals 8x minus 16, distributing, right? It's good times for all. So subtract 3x to this side, and we get 5x, and we get 25 when I add 16, right? So x equals 5, which is just there. All right. In this case, we're going to say, well, you want to double check like which sides match up. But again, we can say sort of 30 over 75 would be equal to, and again, we just want to be clear here that the 30 would be the same thing as, we know that 30 is zx, which is the same thing as pm. We can check this statement. It tells us a lot of information if we were unclear. And then we can sort of reverse that and just say, okay, well, now we're going to do over 75, which is zy, and zy is this one. It matches up with np, so you can sort of see that like it would have to be x plus 5 for that, and 4x minus 10 would match up there. And so, again, make sure we distribute. We'll do 75x plus 375 equals 120 x minus 300. Okay. And so we're going to say, let's subtract and get 45x over here, and we're going to get 675 over here. 675 divided by 45 is 15, so x equals 15. Okay. Got a couple here. Which of the values of y makes the two rectangles similar? So basically, we're solving again. We're writing this proportion, so we're thinking, all right, well, 4.8 over 8.4 has to equal 14.4 over something. So it just becomes a matter of cross multiplying. So we get 14.4 times 8.4, and then we divide by 4.8, and so we get 25.2. Y equals 25.2. All right, and then it's telling us which these are similar. And so you want to look at this. This is important. And so the ratio is 5 to 2 between these two. 5 to 2 between these two. So what does PS have to be? Well, PS matches up with GL. So GL is here. So those are the two that are corresponding. So what I could do is say, well, if the ratio of these is 5 to 2, right? So 5 over 2 is the ratio of all the sides, right? Well, the ratio of this one is going to be 20 to something. So 5x equals 40, x equals 8. Again, I just called this x there because that's what I was solving for. So x has to be 8. In other words, use the similarity ratio instead of matching up the side. You can use a pair of sides to find the ratio, but they're telling you what the ratio is. So again, it's sort of like this is going to be 5 to 2, so they're all going to be those. Okay. Next, explain why 2.5, 1.5, 3.5, and 6, 10, 12 cannot be corresponding sides of similar triangles. Well, if I match up the small to the small, medium, they don't have the same ratios. So they don't have the same, they're not the same ratios. And that's why they can't be similar, because if they were similar, they'd have the same ratios. All right, that's 7.2. Stay tuned for 7.3. Peace.